can't see the screen. Yeah.
Yeah. Hello. Good afternoon, everyone. We are from Puzzlecoders. My name is Sathik Bhattacharjee.
And I'm Abhinaya Mandala.
So today we are presenting our project titled Mystery Puzzle and Escape Room Companion, developed as part of our mobile application development course. So this application is designed to create and play multi-step puzzle missions similar to escape room experiences. The main objective was to build an interactive system that works entirely offline while still providing a smooth and engaging user experience. So, talking about the problems and requirements, the problem that we identified is the most existing puzzle, like the most of the existing puzzle or escape room style applications depend on heavily on cloud services. This limits usability in office environments, offline environments, and adds unnecessary complexities. So to address this, our application focuses on a lightweight offline first approach. Our app allows users to create and manage missions, play missions step by step, track team progress, use hints strategically, and view results like completion time and performance. So overall, the system takes structured inputs like mission steps and produces outputs such as session tracking, progress updates, and final results. So talking about the Flutter and state management, we developed this application using Flutter. And we chose Flutter because first, it supports cross-platform development with a single code base. Second, it provides fast development through hot reload. And thirdly, it enables building responsive and consistent UIs. Now for state management, we use Riverpod, and Riverpod, like we know, offers compile time safety, independence from build context, and better scalability compared to simpler approaches like set state. Now, this makes it suitable for managing complex application state. So if we look at the code snippet that's been provided here, so this snippet shows a future provider, which is used to fetch mission data synchronously. The UI listens to this provider, so whenever the data changes, the UI automatically rebuilds. This creates a reactive system where user actions directly lead to UI updates without manual refresh logic. Now, talking about the UI UX design, our UI follows a detective themed design to match the puzzle concept. We used a consistent color palette with darker tones and highlight colors to create a mystery style experience. We also focused on reusable components, clear navigation, minimal and uncluttered layouts. This ensures the interface, which is interactive, intuitive, and easy to use. Now for navigation, we implemented bottom navigation with an index stack. This helps preserve the state across tabs so users don't, lose their progress when switching screens. Now, talking about local data SQLite, which is the database. So to support offline functionality, we used SQLite for local storage. We structure the database into tables such as mission steps, missions, teams, and game sessions. This, and etc. Of course. This ensures organized and relational data storage. Now we have added a snippet of the schema. So if you look at the schema represents the mission steps table. Each step is linked to a mission using a foreign key. We also store step title, order index, clue, or hint content. Now, the on delete cascade constant ensures that when a mission is deleted, all related steps are also removed. Now, this really helps maintain data consistency. Now, let's talk about the CRUD and shared preferences. We use the repository pattern to maintain a clean architecture. This ensures that the UI does not directly interact with the database. And talking about the code snippet that's here. Now, these functions represent CRUD operations such as fetching all missions, retrieving by ID, and creating new missions. This abstraction improves maintainability and testing. And we also used, like you can see, shared preferences for lightweight storage. This includes theme settings, timer preferences, last active session, which allows us to efficiently manage small pieces of data separately from the database. Now I would like to hand over it to Abhinaya. She would explain the rest of the presentation.
Yeah. Coming to the, can you, yeah. Yeah, coming to the dependency injection and version control, we have implemented the dependency injection using Riverpod providers. This centralizes the object creation and reduces the tight coupling between the components. For version control, we used Git, and each feature was developed with the structured commits. Like, for example, implementing the hint system involved database changes, the logic updates, and the UI integration. Everything is tracked clearly, And coming to the feature trace, play a mission. Like, this slide completely explains the flow of the play a mission feature. Like, when a user starts a mission, the app navigates to the mission player screen. Data is loaded using Riverpod. A session is created and stored in the database. The UI then updates in real time to show the progress, the steps, and hints. Like, this demonstrates a complete flow from user action to the UI update, and we can see this during the demonstration of the app. Coming to the state management and data integrity, we can see that Riverpod acts as a single source of truth across the application. This ensures consistency in data across all the screens. We use set state only for small UI updates, while the Riverpod handles the global state. And if you can see the code, this condition prevents duplicate hint usage. Like, if a hint is already used, it cannot be reused. Like, we also ensure they enforce this at the database level using composite keys. This ensures the strong data integrity and also prevents the inconsistent gameplay. Coming to the graduate features, to enhance the user experience, we implemented additional features such as the animations, notifications, and JSON export functionality. And the code which is displayed, it is a snippet which shows a local notification triggered when a mission is completed. This provides immediate feedback to the user and improves the engagement. And coming to the testing and documentation, we followed a structured testing approach: the unit testing for logic, the widget testing for UI, the integration testing for complete flows. And we also documented the project using README, architecture details, and the inline code comments. We focused on documenting key components necessary for understanding and maintaining the application. And to conclude, we developed a fully functional offline mobile application using Flutter and Riverpod. We used SQLite and SharedPreferences for data management. And we also followed clean architecture principles with additional features like notifications, animations, and structured testing. So, yeah, thank you. And I would like to share my screen and show the application. So, Satvik, can you?
Yeah, absolutely.
Can you see the screen?
Yeah.
No. Now, am I audible?
Yeah, absolutely.
Okay. Okay. So as you can see, this app is a mystery puzzle or escape room game where users can browse missions, solve puzzles step by step, and complete the challenges within a time limit. The idea of the app is to simulate a real escape room experience digitally with clues, decoding, and progression. So if you can see here, this is the home screen, which acts as the dashboard. Then if you can go to the missions, this is like if you want to play a mission, and we have different kinds of mission. And coming to the browse missions, I mean, the users can explore different puzzle missions, and each mission can be edited. To do that, first we need teams. You can see the it supports a multiplayer or tracking sessions. So if you want to play a mission, like you can quick directly access to jump into the gameplay, and this allows saving or analyzing gameplay data. And users can add their teams here by giving their team name, and they can create their team name, and only then they can play the missions. And we have three different missions which has different themes. And if we get into details, yeah, here, everything has steps. Like each mission is containing steps. Before creating a mission, I mean, user can give a title and a short description of the mission, and then get into the details by adding the information and all. And here, each mission starts with a narrative to make it engaging, and the mission is divided into these steps, like find the hidden key or decode a message, unlock the drawer or the escape, etc. And each step has a time limit, adding the difficulty. And this includes the logic puzzles like Caesar cipher decoding, etc. So the app combines the storytelling plus puzzles plus the time pressure to create an interactive experience. And yeah. This is the leaderboard, the achievements, and the story where people can get into a leaderboard like every time they play and win. So yeah, this is the app, and you can even change the mode. This is the leaderboard, and this is the achievements and story. So
Thank you, Abhinaya.
yeah,
That was a great explanation. All right. Thank you, everybody, for watching the video.
thank you.